Today I'm going to talk about the definite integral and its relationship to the area under a curve and how we can put those two things together. So the definite integral represents a signed area. Like velocity, where positive is going right and negative is going left, velocity gives direction, the integral gives a signed area. Above the x-axis is positive, below the x-axis is negative. Before we talk about using formulas to find the definite integral and using integration, we're going to look at it using geometry, so from a geometric perspective. So if I want the integral from -3 to 3 of the square root of 9 minus x squared, this represents a semicircle centered at 0, 0 with a radius of 3. So the first thing I'm going to do is draw a diagram and that's the area that we're talking about. I know the area of the circle is pi r squared. Since this is a semicircle, I'm going to have 1/2 pi, a radius of 3, and I'm just going to leave my answer as 9 pi over 2, because that's the exact answer. We could not evaluate this integral analytically, but we can do it geometrically. If I have the integral from 0 to 3 of x plus 2, my x values are between 0 and 3. This is a line. My y-intercept is 2. My slope is 1. So I'm going to draw the line, shade my area, and I see that what I have is a trapezoid, but I'm actually going to divide that up into a rectangle and a triangle. So the area of this rectangle, 3 times 2 is 6. The area at this point here, if I substitute in 3, is 3, 5. So this distance is 3. This distance is 3. So the area of the triangle is 1/2 base times height. So 9 over 2. So my area here is 6 plus 9 over 2. So I could say 12 over 2 plus 9 over 2, 21/2 or 10.5. This is an integral which we will learn to calculate analytically. Sometimes you're not given a function, you're just given a graph. So if I look at this graph here, I can see it's made up of a series of lines and geometric shapes. If I look at the integral from 0 to 2, that gives me this triangle. It is below the x-axis, so I know my answer is going to be negative. The area of the triangle is 1/2 base times height, so 4 divided by 2 is 2. The area is 2, but the integral is -2. Now the next integral is from 2 to 4 of f of x dx. So my height here is 1, so I have base times 1, another triangle, divided by 2. That's above the x-axis, so that definite integral is 1. Next, I look at the integral from 2 to 9. I've got from 2 to 4. I'm going to do the same thing I did last example and divide this up into a rectangle, which is 3 by 1, so this area is 3, and a triangle, that area is 1. So if I look at the whole integral from 2 to 9, that's 1 plus 3 plus 1, and that area is 5. and it's all above the x-axis. Finally, the integral from 0 to 9. I know from 2 to 9 I have 5. This is a negative 2, so my final answer, 5 minus 2, is 3. Finally, definite integrals, like derivatives, have some properties. We can add or subtract integrals. We can multiply or divide by a constant. We cannot multiply or divide two functions. Like with the derivative, that creates a product rule or a quotient rule. So let's look at an example where we're given some values of definite integrals and we're going to use those. So the integral from 0 to 5 of f of x dx is 9. The integral from 3 to 5 of f of x dx is 2. And finally, from 0 to 10 of f of x dx is 21. The first property has to do with when I switch my boundaries. I'm going backwards. So all that does is changes the sign of what my original integral was. When we do the fundamental theorem, we'll see what happens as we subtract in the opposite order. So if the integral from 0 to 5 of f of x dx is 9, the integral from 5 to 0 is going to be negative 9. Second example, if I go from 5 to 5, if I think about the area concept of the integral, that means I'm starting at x equals 5 and I'm ending at x equals 5. So I'm not actually getting any area. In that case, the integral is 0 because I'm not mapping out any area. Finally, if I want the integral from 5 to 10 of f of x dx, I know the integral from 0 to 10 is 21, and then I'm going to subtract that first part of the area. So really what this is the integral from 0 to 10 of f of x dx minus the integral from 0 to 5 of f of x dx. In other words, I'm just taking that first part of the area off. So if I do 21 subtract 9, that gives me 12. Lastly, we can multiply by a constant, or we can add just a constant out and back. So if I have the integral from 3 to 5 of 4 times f of x plus 1 dx, I'm going to think of that as two different integrals. This 4 just makes the graph 4 times as tall. So if I think about that with the area perspective, this is going to be 4 times 2 for this part of the integral. If I look at the second part of the integral, plus 1, the graph of y equals 1 is a horizontal line. And if I look between 3 and 5, that gives me a rectangle of area 2. Another way I could think of this is 1 times the difference, 5 minus 3. So this is 2, so 8 plus 2, the final answer here is 10.